Hello, and welcome to North Carolina State University. My name is April Dillon, and I am the Area 4-H agent for the West Region in North Carolina. About 8 years ago, I trained with Princeton Review in North Carolina State University to become a facilitator for the ACT test. NC State University collaborated with Princeton Review to provide the ASPIRE program. ASPIRE stands for ACT Supplemental Preparation in Rural Education. It is designed to improve scores in high school students' performance on the ACT college entrance exam. As a high school student, preparing for a college entrance exam like the ACT can be pretty difficult. Cooperative extension agents and public high school teachers have teamed up to offer courses in counties to prepare sophomores and juniors for the ACT college entrance exam through the ASPIRE program. The information that I'll be sharing with you today comes from the Princeton Review course workbook for the ACT, which is used for the ASPIRE program through North Carolina State University. Today, we will focus on tips to help you improve your science ACT score. So grab a pencil and paper and we'll get started. The science test gives you 35 minutes to answer 40 questions. There will be 6 or 7 passages. Most passages will feature at least one chart or graph. One passage is likely to be all or mostly text and will be similar to doing the dual passages in reading. The order of the passages will vary, both in difficulty and type. The number of questions that test knowledge of actual scientific facts will be few to none. This is not a test of science facts. It's a test of science reasoning. The bulk of the questions require you to spot, evaluate, and synthesize trends and relationships in figures and viewpoints. So look out for those trends and relationships. All of science, particularly the scientific method, rests on a broad application of common sense. Expect only 1 or 2 questions on basic facts that the ACT expects most high school students to know about science. Let's talk about the passages. Now passages, those that you should do first, will feature relatively small tables and graphs, numbers, not words or symbols, easy to spot consistent relationships, and short answers featuring numbers or words such as increase and decrease. Let's talk about the questions. You'll have some now, later, and never questions. Now questions are going to ask you to look up values or relationships. Now questions may ask you to make a prediction. Later questions are those that you can get to after answering your now questions. They may ask you to synthesize information. Never questions are those that only if you have time for do you go back and attempt to answer. They may ask you to do some reading and require you to draw conclusions. When you are considering your personal order of difficulty for answering questions, which of these 2 questions should you answer first? Which would be a now question and which would be a later or never question? Obviously, question number 3 on our left is a now question. In this now question, you don't need to know what the mitral valve is. You only need to look up a number in a figure. It is a now question because the question is short, the answers are short, and the answers are in numbers. Now let's look at question number 2 on our right. It requires reading the passage because it is asking you to synthesize information. The question also has longer answers, which indicates reading is necessary. Question number 2 would be a later or maybe even a never question. Let's talk about the basic approach to the science test. First, you always want to work the figures. Mark any trends and carefully note the units. Next, work the questions. Look up answers based on how you mark the figures and read only if and when you need to. Lastly, work the answers using process of elimination. Let's take a look at this figure. What are the variables? They are temperature along the horizontal axis and solubility along the vertical axis. And what are the units? The temperature is in degrees Celsius and solubility is in grams of solute per 100 milliliters. Make sure that you carefully note the units. What is temperature doing in this figure? The temperature is increasing. And what is happening to solubility in this figure? It is also increasing. When you look at the curves, what direction are they generally headed? They are in an upward direction. So what type of relationship is this between the two variables of temperature and solubility? This is what we call a direct relationship. After working the figures, next we work the questions. Based on the figure, as temperature increases, the solubility of KNO3 does what? This is a now question. Why? Because it asks us about a relationship from the figure. We already spotted that relationship when we worked the figure. So the answer is F. It increases. Let's work another question. According to figure 1, KNO3 and NH4Cl have the same solubility at what temperature, if any? This question tells you which figure to look back to in the passage. It is also a now question because you are looking for a value. Take a moment to select your answer. Let's talk about it. They intersected just before 30 degrees, so the correct answer is B, between 20 and 30 degrees. Let's take a look at these two tables. In Table 1, what are the variables? They are velocity, radius, and frequency. What are the relationships between the variables in Table 1? When the velocity increases, the radius increases, but the frequency remains the same. There is no change. When you work the figures, mark the trends you see with arrows, as I have done here with the red arrows. Velocity increases, so we give it an arrow pointing up. Radius increases, also an arrow pointing up. Frequency remains the same, so we draw a flat line. In table number 2, what are the variables? Here, we have magnetic field strength, radius, and frequency. What are the relationships between these variables? When magnetic field strength increases, radius decreases, and frequency increases. When looking at these two figures, how does experiment 3, represented in table 1, differ from How does experiment 1, represented in Table 1, differ from experiment 3, represented in Table 2? The microfield strength replaces velocity as a variable and frequency increases. So what does that tell you about what affects frequency? We know that magnetic field strength affects frequency as shown in Table 2. The previous two tables actually come with passage about 3 different experiments. With this question, we will see why you should not read the passage unless you have to. Here's the question. Based on the results of experiment 1, Table 1, if an electron were shot into a cyclotron with a velocity of 5,000 meters per second, the radius of its orbit would most likely be what? This is a now question because it points you back to a figure, Table 1, and because the answer choices are short and include numbers. It is asking us to make a prediction. Take a moment and select your answer now. Let's talk about it. A velocity of 5,000 is not on the table, but we can predict that the radius should double if the velocity doubles. So if you selected answer choice H, 28.4, you are correct. Sometimes science passages have multiple figures that seem unrelated to one another. The key to decoding passages with such figures is to find the link between the figures. There will always be one. What does figure 1 show us? It shows us the water in aquifers from the years 1950 to 2000. What does figure 2 show? It shows the rainfall amounts from 1950 to 2000. So what is the link between these two figures? In both figures, we're talking about the water that is available, 1 in aquifers, 2 in the amount of rainfall, between the years of 1950 and 2000. Now let's look at figure number 3. 2 pie charts. Pie charts of the land use in 1950 and 2000. So, thinking back to the previous 2 figures, what are the links between figures 1, 2, and this figure 3? It would be the dates 1950 and 2000, as well as the location of Maricopa County. That wraps up today's science lesson. Don't forget what those now passages feature. Relatively small tables and graphs, numbers more than words or symbols, easy to spot relationships and trends, and short answers such as increase or decrease. And most importantly, remember the basic approach for science passages. First, work the figures, marking trends and relationships. Second, work the questions and read the passages only if you have to. Last, work the questions using process of elimination. By participating in an Aspire class, you will learn the latest tactics and strategies to improve your ACT score. The program is open to high school sophomores and juniors and includes 30 hours of ACT course instruction where students will learn the skills that they need to tackle the ACT. Students also receive the Princeton Review ACT Study Manual, the Princeton Review 1460 Practice Question Manual, and access to 4 ACT full-length practice exams with score analysis and breakdown. If you have questions or would like more information about the Aspire course offered through North Carolina State University, please contact Bianca Glaze, the Aspire coordinator, at bglaze@ncsu.edu, or you can also contact me, April Dillon, at abdillon@ncsu.edu. Good luck on your ACT.